NAT, what it really is and how it actually works. When people first start learning networking, NAT usually gets explained in a very simplified way. They say it's just address translation and stop there. But if you want to truly understand networks, you need to know what actually happens inside the router and why this mechanism even exists. Let's start with the problem. IPv4 is 32 bits. Theoretically, that gives about 4.3 billion addresses. In reality, fewer, because some ranges are reserved. When the internet started growing massively, it became obvious that we would run out of addresses. If every device in the world had its own public IP, the pool would be exhausted very quickly. The engineering solution was elegant. Private address ranges were introduced. These addresses are not routed on the public internet. ISPs simply don't forward them beyond their infrastructure. But that raises a logical question. How do devices with private addresses access the internet at all? That's where NAT comes in. No marketing, no myths. NAT is a mechanism that modifies packet headers as they pass through a border router. The key word is modifies. It doesn't mask traffic, it doesn't encrypt anything, and it doesn't make you invisible. It simply rewrites fields in the IP header, and often in the TCP or UDP header as well, in real time. Let's walk through a real scenario. Imagine a home network. You open a browser and visit a website. Your laptop creates a TCP packet. The packet gets sent to the router. If the router forwarded it unchanged, it would be dropped on the internet because private IPs are not globally routable. So the router performs translation. It changes the source IP to its own public IP. Then it changes the source port, for example, to 4001. After that, it creates an entry in its NAT translation table. This entry links the internal IP and port to the external IP and new port for that specific protocol. Now the packet goes out to the internet as if it was sent directly from the router's public IP. When the server replies, the router checks its NAT table, finds the matching entry, and rewrites the destination IP, then it forwards the packet inside the local network. The connection continues. No magic, just a translation table and header rewriting. The most important thing to understand is this. NAT creates state. Every connection creates an entry in a table. That entry stores the internal IP, internal port, external IP, external port, protocol, and a timeout value. If a connection is idle, the entry gets removed after a timer expires. If the table fills up, new connections can't be created. Any mechanism that creates state can become a point of failure. You can have exhaustion attacks, table overflow issues, problems with peer-to-peer connections, VoIP complications, and limitations for incoming connections. That's why NAT is not a security feature. It's an architectural compromise that extended the life of IPv4. Why can't you just connect to a device behind NAT from the outside? Because there's no matching entry in the translation table. By default, NAT only allows return traffic for connections that were initiated from the inside. If a packet comes from the outside without a corresponding entry, the router has no idea where to send it and simply drops it. That's why port forwarding, static NAT, DMZ, UPnP, or VPN tunnels are used. IPv6 significantly reduces the need for NAT. IPv6 uses 128 bits, which provides an enormous address space, enough to give every device a global address. In theory, NAT is no longer necessary. In practice, it's sometimes still used for organizational or policy reasons. The key takeaway: NAT does not encrypt traffic, does not inspect packet content, and does not fully protect a system. It simply rewrites headers and maintains a translation table. If you don't understand NAT, you won't fully understand how reverse shells work, why certain attacks fail, what double NAT is, why gaming servers sometimes don't connect, or why a port looks closed even though a service is running. Networking is the foundation. Exploits are secondary. Without understanding network logic, cybersecurity becomes guessing, and NAT is one of the fundamental building blocks of that logic.